Hi students, in this video we are going to study about our fifth unit, crystallography and X-ray diffraction. Okay, let us see. In general, the matter exists in three different states. That's the solids, liquids and gases. Solids are classified into two types. That is a crystalline solid, non-crystalline solid. That means amorphous solid also. Because non-crystalline means amorphous. It is a powder format. Okay. Crystalline. Let us see what is a crystal. The atoms are arranged in a periodic manner in all three directions. There are two types, single crystalline and polycrystalline. That means inside a crystal the atoms are arranged in a periodic manner in three directions. So like that, those are two types. One is a single crystalline, polycrystalline. So single crystalline. What is the entire crystal consists of only one crystal. That is one crystal structure. Polycrystalline. The polycrystal is an aggregate or many small crystals separated by well-defined boundaries. Okay, so that is known as polycrystal. Grains is nothing but a powder that can be deviated into small grains. In polycrystalline solid, periodicity extended to very smaller region, then it is known as grains. Okay, let us see what is a non-crystalline. That means amorphous. In amorphous solids, the atoms are arranged in randomly and they have no directional properties. Okay, in crystalline solids, those are arranged in periodic manner that are in all three directions. But in case of non-crystalline solids, those are the particles, those are the crystals, those are the solids, those are no directional. That means doesn't have any directional properties. Unit cell. The unit cell is the smallest unit which, when repeated in space identically, that generates the space lattice. Okay, the unit cell is the smallest unit which repeated in small identical generates the space lattice. I will show the diagram of unit cell also. Okay, let us see what is the basis. A group of atoms or molecules identical in composition is called the basis or the pattern. Okay, lattice plus basis gives the crystal structure. Okay, and next see what is the lattice parameters of a unit cell. See here, this is a unit cell structure. The line drawn parallel to the lines of intersection of any three phases of the unit cell. That means the line drawn parallel to the lines of intersection of any three phases of a unit cell which do not lie in the same plane, that is called a crystallographic axis. Okay, see here what are the crystal axes. Naturally, three translational vectors A, B and C lie along the crystallographic axis. The intercepts A, B and C define the dimensions of a unit cell and are known as primitives. So these are known as A, B, C. Those are known as primitives. Okay, this is the unit cell structures and these are the crystal axis and these are the parameters. That means known as primitives. Okay. Next, the previous figure shows a two-dimensional crystal structure and figure B shows a three-dimensional crystal structure. Okay, this is the two-dimensional crystal structure and this is the three-dimensional crystal structure. So this is the cubic unit cell. The angles between the three crystallographic axes are known as interfacial angles. The angles between the three crystallographic axes known as interfacial angles. And now the primitives A, B and C, those are the interfacial angles. These are the primitives. A, B, C are the primitives according to this. and alpha, beta, gamma are three basic lattice parameters. Okay. See, there are several structures according to the crystal. All those are given here. Okay. Let us see. When it is a cubic structure, all the parameters A equal to B equal to C and all the angles equal to 90 degrees, like this. So these are the examples for cubic structure. Okay. And next, tetragonal. These are the lattice parameters. So A equals to B but not equals to C. When here the C is different from A and B. Alpha equals to beta equals to gamma equals to 90 degrees. Means all the interfacial angles are equals to 90 degrees. So these are some example for tetragonal crystal systems, and this is the shape of the tetragonal crystal. And next, orthorhombic. Orthorhombic means all the three primitives are different. So A, B, C. See here, A is different, B is different, and C is different. So A not equals to B not equals to C. And all the angles are same. The interfacial angles alpha, beta, gamma, that is equals to 90 degrees. So three are perpendicular to each other. So these are the examples for orthorhombic crystal structures, and this is the structure of orthorhombic. And monoclinic. This here also all the primitives are not equal, but alpha equals to beta equals to 90 degrees but not equals to gamma. These two here, see, A, B, this is equal. The interfacial angles here is equal but with not equal to gamma. Okay. This is the orthorhombic structure. And next, monoclinic. It is also over. Next, triclinic. Triclinic means here all primitives, the three interfacial angles are different. A not equals to B not equal to C, and alpha not beta not equals to gamma not equals to 90 degrees. Completely three different interfacial angles and three different primitives. Okay, these are the examples, and this is the structure for triclinic. And next, rhombohedral. Rhombohedral shape, that is nothing but a trigonal. Here A equals to B equals to C. The primitives are same. Alpha, beta, gamma, those are alpha equals to beta equals to gamma but not equals to 90 degrees. Okay, see here, this is the alpha. And next, these are the examples for rhombohedral structures, and this is the structure. These are some examples. Hexagonal, that's a 6. Hexa means 6. So A equals to B but B not equals to C. A equals to B but B not equals to C. And alpha equals to beta equals to 90 degrees. Alpha and beta is the same here. It has a interfacial angles 90 degrees but gamma equals to 120 degrees. Okay, and here the quads and some other examples for hexagonal structures. Okay.